The homework from last week. So the homework was to make Link that looks like this, move up, down, left, and right, and based on the direction that you move, he's supposed to look like this. So move up, down, left, right, and be animating as you move him. So this was an extension on the, hey, move your white rectangle around with up, down, left, right. And it included the ability to switch from the texture that was assigned. So the texture looked like this. So from this texture to pick the correct series of animations to play based on the direction that you're moving. There is a bunch of other animations here, like attacking downwards and attacking to the left and right and above, as well as it looks like different armor sets. So you can have like different swords and stuff, which is cool. Yeah, it does look like a little bit like Terraria or Stardew Valley, a little bit. Yeah. This is apparently the Ocarina of Time in like 2D form. So let's first start off. I'm going to start off with a blank project just to show you guys from scratch how you can make this work. Here's what we're going to do. Copy of this. Most of this homework was all about like figuring out how do you actually get Link animating, like moving him around. Should have been pretty straightforward considering you had that already earlier. So let's just start off with this. It's my green circle. Cool. Make this darker and a little bit more legible. And stop me at any point if you have questions about, you know, how you did it or if you're not sure how it's being done. I'm going to use a rectangle. And I'm going to make this thing a 100 by 100 pixel rectangle. And we're going to make this thing white. Let's just start off by having something that moves around with the keyboard. So there's our Link graphic. Remember, there's multiple ways that you can have handle keyboard events. There are events that get passed in from Windows. So this is inside this loop. You will handle any events that Windows tells you about. So these are events like, hey, I pressed a key or I released a key. And then there's a series of functions you can call to ask, hey, is a key currently being pressed right now? And the ones you want to use for moving are the ones where you ask, hey, is this key currently being pressed? Because when you're moving a character around in a game or like a paddle in Pong, you want that response to be immediate and consistent. Like you don't want to rely upon Windows to tell you that the player is holding down a key because that will introduce a delay that you don't want. Otherwise, it'll take some time for your character to start moving. So what we'll do is, first of all, we need to just have this thing set up so that it'll actually move the character in the right direction based on the direction that you're moving, the key that you're pressing. So we're going to say if is key pressed. So if I press, let's do right first. And we're just going to call shape.move, and we're going to move him 0.1 to the right. So I can move this thing to the right. Cool. And you can follow this pattern for the all four directions. So copy paste is your friend here because you can do all these things are essentially the same. The only difference is that the direction that you're moving as well as the key that you're pressing. So I'm going to change all these to make more sense. Okay. Just putting zeros here to be more clear. So with this setup, you should have a rectangle that is allowed to move diagonally up, down, left, right, like so. You can move it around, and you can move this rectangle. You can imagine this is basically Link. With just that little bit of code, we already have like an interactive experience for our game, which I think is pretty cool. One thing to note is that we're going to dive more into this today, is that this amount that I'm moving is 0.1 pixels every time this loop runs, which means the faster this loop runs, the more often this gets called. And this means that on different computers, the character is going to move at different rates. So we don't really want this to be 0.1 here, because we want this to be based on time, not based on how fast your computer is running. So we're going to go over that in more detail today, because this right here is fine for like quickly what we're doing right now, but it's actually not going to really work great for when we actually want to do very precise, specific velocities on your games. For instance, like in Overwatch, May's ice projectile flies at like 1,400 meters per second, or something crazy fast, but that's a very specific time, and it's a very consistent time that we want to fly. We obviously don't want that to fly at different speeds based on what computer you're playing at. That has to be a very consistent speed, which is why we're going to learn today how to actually make things move with real velocity. All right, so now what I want to do is I want to load up a texture of Link. And we're just going to pass in directly to the file. And we're going to say, hey. And another thing here is that up to this point we've been failing and we've just been printing out. In reality though, our game doesn't really work unless Link is loaded. So all I'm going to do here is I'm going to return 0. Doing this when you fail to load will mean that your game will start up and then immediately close if you can't load the texture. Let me show you what this means. So I'm just going to print out I'm just going to print out to the screen when I failed to load this texture. So I know there's a texture inside here. Oh, I thought there was a texture. Oh, it's in the week 5. So we're going to put these textures in here. Cool. I'm able to get into the game, but what happens if I just like rename the Zelda texture inside here? So if I rename this one like Zelda 2 and then run this, I'll put a breakpoint in here. So see how the yellow arrow is inside here, which means it's going to run this code and immediately exit. So watch what happens to my game when I run this now. See how it immediately closed? It like fails to actually load the texture, which means nothing actually happens, because this right here is we're doing an early return out of this function. Okay. Something you want to keep in mind, if you can't actually play your game because you're failing for some reason, then you should print an error message and consider not even running the rest of your game too. Sometimes it might be okay if it's like a white texture. So if I do this, what'll happen is that it'll continue to load. I still have white texture, but you can see up here in the left corner, I have this error message that I wrote. Failed to load, unable to open file, failed to load link texture. All right. So now that I have a link texture, what I'm going to do is I'm going to create a link sprite. Set texture. And we're going to pass in the link texture here. Actually, we don't even need a sprite. We already have a rectangle. Let's do this with the... okay. Because I think in the homework I asked you to just use the existing shape. Remember, this thing takes a pointer. This function takes a pointer. You can see a little asterisk there, which means you have to pass in a memory address. And remember that you get the memory address of a variable by passing in ampersand in front of it, if it's not already a pointer. All right, cool. So now we should have our rectangle be the texture. So you have this like tiny little, you have this link texture that's mapped onto a white rectangle of that size. You can't really tell because it's being squished, but if I were to blow this up like 4 times bigger, this is the next Zelda game by Nintendo. You just play every Zelda at the same time from all the generations.
At this point, don't give them any ideas.
Yeah, who knows? With E3 coming up, I'm actually interested to see how that's apparently all they're bringing is Zelda. They're not bringing anything else. No news about anything else. No news about NX. No Pokemon news. No nothing.
What else do they really have to say, though?
Yeah, just Zelda. What's that?
Nintendo's an interesting company.
Mm-hmm. I think it's funny because some people I think are worried that, you know, with the Wii U not doing so well, like, oh, Nintendo's not really making as much money, what's going to happen? Without realizing that, like, they have Pokemon, and, like, Pokemon is probably, like, the biggest selling mobile game. And I feel like they always have something in their back pocket. If they ever need money, all they have to do is either A, make another Pokemon game, or B, if they really want, like, a ton of money, they just have to make a Pokemon MMO. And then people will just pay like a ridiculous amount. Yeah, but I don't know if that's an MMO in traditional sense. It's like the mobile game.
You're going to be fighting against other people.
Yeah, but it's not quite the same as like a Pokemon MMO on a console.
Mewtwo has appeared.
All right, so in addition to specifying the texture, we need to also specify the position and size of the rectangle we want to draw from the texture. So in this case, I believe he was, what, 40? I think it was 40. So if I just pick this one, now I get Link, and now he's moonwalking around. Cool. So the key here is that this 0 and 0 indicate the top left corner of the rectangle that we want to use from this texture. So 0, 0 is this top corner, so if I want to like Epona, I would draw 1, 2, 3, 4, 5, 6, 7, 8. So I go 8 rows over. So 8 times 40. And this would get me, hopefully, Epona, like so. Right. So by using that knowledge, I can choose what direction I want Link to face. So down, I know he's in row 0. This is row 1, row 2, and then row 3 for all the other directions. So if I have a variable that's called row that controls which row I want to draw from, and here, I'm going to move this code down below, I can just change this to be row times 40, which will change the row I'm currently on based on what this variable is. So depending on the direction, I know that right will be row 3. So I can set row equals 3. If I press down, row can be 0. And up is row 1. And left is row equals 2.
So much less complicated than we did.
This is more complicated than you did it?
Well,
No,
how you
less.
guys did it.
Like it's less complicated than.
Yeah, so when I press up, all you do is change the row that you're on. Okay. Now he's changing directions. He's not animating yet, but he's changing directions. Last week, a bunch of you guys were asking for help or tips on what to do, and one of the tips I gave you was to always be animating Link. Right? You'll always want to be animating. So how does animation work? Well, animation works because you will cycle through the frames. You'll change the column that you're on, and it will reset back to the beginning once you're done. Link here has 8 columns that he's on, so once he's gone through all 8 columns, he needs to start back at the beginning. So if I make a column variable, right, and remember when I said that if you want to animate, I'm going to show you guys how to animate with time. Let me just show you how to animate with a counter again, because that's a little bit easier. If I just add 1 to counter, and if the counter is greater than 100, I just increase the column by 1. And then if the column is greater than or equal to 8, set the column equals 0. And that's all you need to make him animate. So that little bit right here will make it so that while he's moving, oh, actually I have to use the column here. Sorry. So what's happening here is I'm adding to this counter variable. And this counter variable is going to reach some number that I pick. And as soon as it hits that number, I'm going to advance the frame by 1. And then that frame is going to be used here. The column that I'm on is going to be used here to control which animation I pick. So this is happening because, as a hint I gave to most of you guys, you always have to be animating. Which means this logic here always needs to be inside the loop. So this is actually inside my main while loop. It's always happening. Also, I'm only ever calling this function once, which means I'm specifying a column and a row, every time, no matter what. So these two variables, if I just change them, they control what I use. So for instance, if I want to make it so I can use Epona here, we can make it so that I can use Epona to animate. Let's see here. Or maybe I can use link here. Let's see, down. Looks like there's one here. How many rows down? 1, 2, 3, 4, 5, 6, 7, 8, 9 rows. And he's looking up, down, left, right. Okay. 1, 2, 3, 4, 5, 6, 7, 8. Okay. So we can change it so that he starts off on row 8. Row 8 will be him moving up from this image right here. Down will be row 9. Left will be row 10. And 11 will be row, or right will be row 11. It's the same idea. Only thing is that now, you see how he switched? But now he's actually it looks like one of the animation frames is actually not quite lined up. See here, on this last column, it's actually not using all the columns that it had. So you can see here it's actually flipping to a frame that isn't there, that isn't actually a walk animation. So just by changing those rows though, like if I just change this here so I animate only 7 frames worth, and I start row off on 8, he's going to start facing up and then move right and then down. It's just a different set of link animations that I pick. And the logic is actually quite simple. The logic is all within here. When I press a key, I move the link. So I move the actual sprite, and I choose what row I want to be on, right? So that's all these if statements are doing. They're just moving link and choosing the row. Here, this is where I'm animating link. Once you hit some number, and this number controls how fast he animates, essentially. So if I double it, he'll animate twice as slow, essentially. This is not using time, but you can kind of see how it still animates okay. It's probably just not as consistent as it could be. All right. And then finally, this is the magic piece right here. You only ever need to call this once. These two variables, they're the things that are changing all the time. And they change based on, this one here changes based on your animating. And this one here changes based on the direction that you pressed on the keyboard. And between the two of those things, you make up movement and animation. All right. Questions? Did anyone do it like this?
No. Yeah.
Something close. It's surprising how simple you can actually get with some of these things. Like, it actually, sometimes you can overthink the solution, or you don't really sure what the solution is, but it's very easy to get down in kind of like this rabbit hole of like, how this is the only way I know how to do this. And I still run into this problem. Like, when I'm implementing something, every so often I'll question, like, is this really the right way to do this? Is there really a simpler way? Isn't there really a simpler way to do this kind of behavior? And sometimes there is, and sometimes there isn't. And when there is a simpler way, it's almost like solving a puzzle. Like, it's like, oh, that's a lot more straightforward than what I thought it could be, and it makes it a lot more easy to read as well. All right, so that's the homework.